Okay, Assalamualaikum and Bismillahirrahmanirrahim and Assalamualaikum and salam sejahtera. Okay, so before this, okay, we stop right here. Okay, so we have the rate of change of y is equal to when x is 2, the rate of change of y is equal to 11. Okay, so this one is positive, and then when x equal to negative 3, the rate of change of y is negative 9. Okay, so here there is positive and negative. Okay, so a positive rate of change, okay, indicate that the function is increasing at the particular point. Okay, if negative rate of change, so the function is decreasing at the point. Okay, and then okay, rate of change of y, okay, which we usually denote by limit delta x approaching 0, okay, and then delta y over delta x. Okay, we can denote by dy over dx. Okay, okay, so this is the previous example. Okay, so we have y of x, function of y, okay, 2x squared plus 3x. Okay, and then if we differentiate, okay, or simply dy over dx, it will become 4x plus 3. Okay, based on the previous example. I'm not sure example, I'll just check above. Okay, so we also can denote differentiation by y prime. Okay, which means the y prime, okay, y prime is the rate of change of y with respect to x. Okay, so it is the process of finding y prime from y, so it is called differentiation. And then we can also set y prime when it is dy over dz, dy over dr, or dy over dw, meaning that the independent variable can be changed. Okay, it's not have to be x only. And then okay, so we have a look at this example. Okay, so this one, the question asks to find the gradient of the tangent. Okay, this is the function, and then we have to find at interval a11 b. This one is not interval. Okay, when interval is marked with this symbol, okay, interval, which means between x only, okay, within x axis only. Okay, x axis. Okay, when it is in bracket symbol, meaning that it is in coordinate with it, which is x and y. Okay, so now what we have to do is we have to find the gradient of tangent, which is the rate of change of y. Okay, so here we have y, okay, equal to x squared. Okay, this is the function given to us. And then we are going to find the y prime, or you can say delta y over delta x. Okay, which is, this is the formula. Okay, x plus delta x minus yx. Okay, and then x plus delta x minus x. So this one can cancel. So what left is yx plus delta x minus yx, okay, over delta x. Okay, so and then So we have yx is x squared, right? Okay, and then we are going to find yx plus delta x. So we just square the x plus convert, substitute this one into this one. Okay, delta x, okay, x plus delta x. Okay, so maybe, oh sorry, maybe should be like this, so you can understand step by step. Okay, x plus delta x, x plus delta x, and then x squared plus 2 x delta x plus delta x squared. Okay, now we just put into the formula here. Okay, so again, just write down yx plus delta x minus yx over delta x. So x squared plus 2x delta x plus delta x squared, okay, minus x squared. Okay, this one is so can cancel this one with this one, and then we factorize the delta x outside again. So what left is 2x plus delta x, okay, over delta x. So we can cancel this one. So finally we can say that, okay, limit delta x approaching 0 of this one. Okay, okay, so when we replace delta x equal to 0, what left is only 2x. Okay, okay, and then we are given we have coordinate like a 1 1, right, and then we have b negative 1 1, and then we have c 2 4. Okay, one more. So this is the coordinate. Okay, so we just okay, so at a, okay, at a 1 1, okay, means the x here, the x is equal to 1. Okay, and then rate of change of y, okay, equal to dy dx is 2x, right? Okay, is 2x, okay, is 2x, okay, this one. So what we have to do is we just have to replace x here with x here. So it will be equal to 1. So equal to 2. Okay, and then at b, okay, negative 1 1. Okay, means x is negative 1. Okay, same process. So 2x we replace with x we replace with negative 1. So it will be negative 2. Then at c, 2 and 4 means the x is 2. Okay, so the rate of change of y Okay, we just write down again 2x. Okay, so replace sorry, the x with 2. So we have 4. The rate of change of y is equal to 4. So next, so okay, this one is just a general knowledge for information only. Okay, so to evaluate the derivative, okay, dy over dx at a specific value of x, let's say x naught. Okay, so we can denote by using this symbol. Okay, the symbol dy over dx, x equal to x naught, or we can also write in this way, and also in this way, y prime in bracket x naught. Okay, and we also can write in this way and this way. Okay, you see in the example, okay, in the last example, say let's say when we say that the x is, we want to find the rate of change of y. Okay, so one. Okay, and then at x equal to 2. Okay, and then we have some line here, and then for simpler notation, we can use y prime and then the x that we use, which is 2, and then lastly the answer 4. Okay, okay, and then for this example, okay, we are referring the figure 1010 here. Okay, and then we have to consider the gradient of the tangent at point A, B, C, D, and E. Okay, and then we have to state whether the dy over dx is positive, negative, or 0. Okay, so we start with B first. Okay, so B, okay, so it is going upward, right? The tangent is upward. Maybe we say like this. Okay, so the tangent is upward from left to right. Okay, so this is positive. And then for A, let's say we use this one. Okay, so for A, it is flat line. So this is 0. Okay, and then for D, left to right, it is decreasing, or we can say it is negative. And at C, the tangent is, okay, the tangent is flat also, so it is 0. And then finally at E, okay, the tangent from left to right is increasing. Okay, so this is positive. Okay, positive gradient. Okay, here. Okay, now we can relate. Okay, small change delta x and delta y. Okay, delta x and delta y means it is changes in x, changes in y. Okay, change in x and changes in y. Okay, so we can see that dy over dx here. Okay, dy over dx is quite similar. Okay, equal to delta y over delta s. Okay, and then if we can twist around, which means we can find delta y, we can find delta x using differentiation. Okay, let's see the example here. Okay, so this is the function given, y equal to x squared. And then we have to find or estimate the change in y, okay, caused by changing x from 3 to 3.1, okay. So this one, this question asks to find the delta y, and then from here we can see that the delta x is equal to 3.1 minus 3, okay. So it is 0.1. Okay, we have y x squared, right? We have y equal to x squared, okay. From the previous question, okay, using shrinking method, we get dy over dx is equal to 2x, okay. So what we have to do is we just write, okay, again, dy dx equal to delta y over delta x. Now we want to find delta y, so it will be dy dx over delta x. So dy is dy dx is 2x, okay. So we just write down 2x here. And delta x we have 0.1, okay. And then this is delta y, okay. So and then we have to replace x with 3, okay, because originally it is 3. So we have 2, 6 and 0.1. Oh, sorry, it's not 6, it is 3, okay. So it will be 0.6. So we have change in y is equal to 0.6, okay. Okay, existence of derivatives. Okay, so derivative dy over dx of a function ys can be viewed, okay, in algebra or in geometrical. Okay, so this is the first one, the algebraic, okay, and then geometrical is this one, the gradient of graph of y, which means you just draw it geometrically, okay, and then find the gradient, okay. Okay, the existence of dy over dx, okay, and then the derivative does not exist at certain points, okay. And then we have to recognize where it does not exist, okay, where the point that it does not exist. Okay, so for example, in the figure A, okay, 10.14a, we see that, okay, so we see that the left hand side, okay, left hand side is okay, maybe we don't have to say the left hand side, okay, we just have to make sure we can draw tangent or not, okay. The key here is can we draw a tangent at distance depend, either can we draw a tangent at the point or not. Okay, so this one at A, okay, this one, okay, at A, it is not possible. We just can say, okay, cannot draw tangent. Okay, same as this one, cannot draw tangent. Okay, in this form, okay, we say it is cusp or corner, okay, as mentioned below here. Okay, figure B, it is a cusp or corner. So in both cases, it is impossible to draw a tangent. Okay, so dy dx, the derivatives does not exist at x equal to a. Okay, and then next example 10. Okay, discuss the following function. Okay, and then state the values of t which derivative does not exist. Okay, so this is the the function. This is the graph. Okay, has been already sketched. So you can see that which point that it is possible to draw tangent. So first at A cannot draw tangent at here. Okay, so it is at x equal to 0. At t equal to 0. Draw tangent. Okay, at t equal to 0. And then this one is the tangent y. Is it? Tangent t. Okay, sorry. So we can see that it is not possible to draw here at this point and this point. So at t equal to negative pi over 2, pi over 2, okay, and so on. Okay, and then we have this graph. So it is not possible also to draw tangent here at this point at t equal to 0. Okay. And then common derivatives. Okay, so actually that is the original of the differentiation. Okay, the rate of change, it just come from the tangent of at that particular point. Okay, of function at the particular point. Okay. Okay, so the original concept, we use the shrinking interval. Okay, we use smaller interval to get the accurate rate of change. Okay, so it also can be called referred as differentiation from first principles. Okay. Okay, so this is the example. Okay, so this is the table that we often use to calculate differentiation. Okay, so this is actually derives, okay, from the shrinking interval method. Okay, so we just go to the example. Okay, so you can see that. Okay, so the question here is differentiate y equal to exponent ax. Okay, so exponent is just we have to bring down the a here as the constant. Okay, and then we have here y equal to negative 7x. So again we have to bring down the constant negative 7 to the side. Okay, to become constant as well. Okay, and then we have okay, y x to the power of n. So what we have to do n. Okay, so n will we will bring down here, and also the power also must be minus with 1. Okay, and then same to this one also. So 5 here, just we bring down here, and then 5 minus 1 equal to 4. Okay, and then for this one, okay, so A, okay, so this is the formula. Okay, so have identify the A and the B. So A is 3, B is 2. Okay, and then we just bring A to the front. Okay, and then become secant squared. So AX 3, okay, 3x. So A here and then B here plus. Okay, if I okay, and for D, so again we have to identify the A and B. Okay, so A is W. Okay, here W, sorry. Okay, and then B is 5. Okay, so we just bring A to the 5, which is W, and then AS plus B. That's it. Okay, and then okay, this form we just turns in to the power of negative 1 over 2. Okay, so we just use this formula. Okay, so negative 1 2 over 2 is bring down here, and then negative 1 2 minus 1, so it is become negative 3 over 2. Okay, so this one is it is negative 1 over 2 minus 1. Okay, so it is negative 3 over 2. The same this one, negative 5, you just bring 1, and then negative 5 minus 1, so it is becoming negative 6. Okay, and this one also we have to pay attention at A and B. Okay, okay, so if cos, it will become S and B. So the question is why cos negative 1 5x. Why cos negative 1? Okay, so this is the question. So it will become, so this one, the A is 1. Okay, A is 1. Sorry, A is 5. Sorry, written here. A is 5. B is 0. So we just convert here the A into here. Is 5 here, and then 0 here. So this is the answer. Okay, and here also the A 5. Okay, okay, the table is not only for independent variable x. Okay, we can also use other independent variable named t, such as the name W. Okay. Okay, so dy over dt. Okay, let's say this is the function. Okay, so again dy over dt also will be named as et. Okay, as in the table. Okay. I think that's it for now. Oh no. One more a little bit, okay? Okay, so this is it. Okay, so this is okay the linear operator. Okay. Which means we can differentiate the sum of two functions. Okay. By differentiating each function separately, and then just simply add the two derivatives. Okay, in this case, okay, let's say we want to differentiate. We have to find the derivative of f and g. So first we differentiate the f, and then we differentiate the g. Just like this one. Okay, this one is the simpler case. Okay, this is how we should remember. Okay. Okay, and then another one is, let's say we want to differentiate kf. Okay, where k is a constant. So we just, okay, first differentiate. We have to find the derivative of kf. So what we have to do is we put the k, constant k, at the front. Okay, multiply with the derivative of f. Okay, so in this case, k here is brought to the front. Okay. Okay. Table 10.1. 10.1. I don't know. Okay, so in this case, let's say we have to differentiate 3x squared. Okay, we have to differentiate 3x squared. So what we have to do is we just identify the constant, which is 3. So bring 3 to the front. Okay, and then we just only differentiate x squared only. So it is 2x. So it is 3 2x, so it will become 6x. Okay, and then for this case also, it is a constant. Okay, this one is a constant, but there's no x, so it will become 0. Okay, and then this one, okay, we have to differentiate this first, and then differentiate this first, and then differentiate first this the last one. And then remember, this one we just make it to the front, bring it to the front, because it is constant. Okay, in this case, okay, in this example, okay, use the table 10.1, okay, and the linearity properties, okay, to find the y prime. Okay, so always, okay, always check the linear property. Okay, okay, so first one is check the constant. Okay, and then second one, check the either we can differentiate separately. Okay, differentiate separately. Okay, so constant. Okay, in this case there is constant here. Okay, and then this one just differentiate. You just change the form into x -1, okay. So it doesn't matter about the linearity. And then for 3, this is constant. Okay, and then this one, we can differentiate separately. Okay, and then this is constant. Okay, okay. And then this one we can differentiate separately. Okay, then don't forget there is constant in each term. Okay, and then for ln 2x, okay, for ln 2x, okay, so we just use the laws of logarithms, which we can separately put into ln 2 plus ln s, and then we just differentiate each term. Okay, so this will become 0 and this will become 1 over x. Okay, so I think that's it for this slide. Okay, thank you very much and Assalamualaikum.